Hi, my name is Roland, and in one of my recent videos we were talking about earthing systems and how you exactly build up your earthing system if you have a grid connection and you add an off-grid inverter to that, and how you transfer this, and I showed you some kind of schematics how to build it up. And I had questions from my followers, and they asked me to show this just for a simple off-grid system, an off-grid inverter supplying your loads, how this would be done correctly with the earthing there. So I have made another schematics, very easy this time, and we will just quickly talk about the different kinds of off-grid inverters you would use in this kind of scenario, and how this is connected. So please bear with me, a very short video about this topic. So before we look at the schematics, how to connect an off-grid inverter, let's just quickly talk about what sort of equipment people would usually use if they do a pure off-grid system. Just like in the case of a small house, you don't have a grid or an off-grid cabin, even maybe a RV or something like this. So you have actually two choices, and the most simplest and cheapest will be this sort of high frequency type inverters. So high frequency or low frequency type, this refers how the inverter is generating his sine wave, and high frequency inverters are the cheaper version of inverters because they internally don't have a big inductors which are then smoothing out that sine wave. They are generating the pure sine wave just by very quickly switching the DC on and off. This type of inverters, if you go for something like this, they are by design purely meant to be used as IT earthing system, isolated earth. That's why they are built like this. They are the inverter, and then they have a socket, and you are supposed to use this socket straight with the device you want to run on it. So the worst thing you can do with this sort of inverter is connect an extension cable here, which again has like 3 to 5 sockets on it, and you fill up those sockets on the extension cable, because as I said, in the IT system, by having a fault on one of the devices, the fault can be replicated to the other devices. So this would not be the correct way. You can still use an inverter like this, and I will show you then this, of course, in the installation schematics. The other type, you will have seen it already like this, the low frequency type inverters, very heavy, more expensive. The reason, there is a big transformer inside of this, and the transformer is responsible to smooth out the sine wave. And it has one big advantage: this type of inverters can surge very high, so they can surge up to 3 times their nominal current without shutting down for many seconds. So these ones are perfect to be used in like small buildings or cabins, something like this, because you can connect power tools and all that kind of sort of devices, which also are inductive loads which surge, and so this is the way to go. And they also come with terminals, so you can perfectly connect it into your system. The other one, very cheap, but if you want to go for a permanent off-grid installation, go for something like this, for a low frequency type inverter. So every time we build up a system at home, small system, we will go for the TNS system, because that system gives us already a return path, a double return path. So in case of a earthing fault, a return path to the source of power with 2 wires, more or less, right? Because N and PE is anyway connected, somewhere bonded. So we have a double protection in the TNS system, so that's why we go for this one. But you will see the bonding, usually TN means that the earth and neutral are bonded at the source of the power, and that would actually mean, if you see it correctly, that the bonding would have been done somewhere here already, right at the inverter. But we are not going to do this by obvious reasons, because the connections can be much easier made and more solid inside the load center. And when you build an off-grid system, I'm pretty sure that your load center, your breaker box, will be right next to the inverter, and the rod will be right next there, because you will build this all at one place anyways. So how do we do this? We have our 3 wires from the inverter going to the load center. If you have a split phase, you have 4 wires. But you have your L, you have your N. Those are going straight into the input of the RCD, and you have your PE, which will come from the earthing rod. The earthing rod we will connect at our load center to the PE bar, because that is the solid place where we can do that best. And therefore we will have to use an extra earthing cable, a wire, to go to the inverter. Now, most of the off-grid inverters will have somewhere a symbol like this and a screw with a nut. You can see it here on this inverter, or here on this inverter, and that is a grounding point. So when you have a grounding point, you connect the earthing wire to that grounding point. But please use a multimeter and check for continuity between that grounding point and then at the terminals where you have the PE there, or here in these sort of inverters. Check if there's continuity between the earthing pin and that grounding point. So this will tell you if there is an internal connection. If not, you will have to make a connection also to the output of the inverter PE, so that all the grounding points are connected. After that, here inside the load center, there's one thing then missing. We need to bond now. So we take a jumper from the PE bar and go to the input side N to the RCD. This is now our bonding, and we have turned the IT system into a TN system. Yeah, and the outputs of the RCD, as everywhere else in every different system, L goes then to the individual circuit breakers, and you use them to supply your loads, and the output of the neutral goes to the neutral bar, and you take the other neutrals to your loads. If there is anything else to bond to earth, like metal pipes, gas pipes, copper pipes, whatever, you also bond it to your PE bar here. That's already it. So if you have this sort of inverter which only has a socket, you have to make yourself the connection cable with three wires. So separate LN and PE to connect it to your load center. And if you have an extra grounding point, then you also connect this one to your PE bar with a solid connection. Any failure in your electrical system will be then taken care of your RCD. That was it already. So it doesn't matter what type of inverter you take, the cheapest ones or those which are really supposed to be installed in an off-grid setup. The right way to do it is always via a load center, a breaker box, where you then really connect everything nicely and safely, so that there is no weak points in the cabling there. And the rest will be taken care of your RCD. So do not use extension cables on an unearthed inverter, because that would more or less misuse the IT system, and that is not safe. So please, if you have examples how you did it in a small installation and you're running it off-grid, you can share your experiences in the comment sections below. And yeah, so thank you for watching. Please subscribe to the channel, like the video, and I see you next time.